So the power of a product, this is when I have a product in parentheses and I'm raising the whole product to an exponent. So here they have 2 times 5 to the third power. That means I'm going to have 2 times 5 times 2 times 5 times 2 times 5, which they would have 2, 2, 2, 5, 5, 5, which is 2 to the third power and 5 to the third power. So let's see if we can do it with this one. 3x to the fourth power. So we have 3x times 3x times 3x times 3x. So now we get to separate it. How many 3's do we have? We have 4 3's. And how many x's do we have? We have 4 x's. So 3 times 3 times 3 times 3 is 3 to the fourth power. X times x times x times x is x to the fourth power. Interesting. So now we have to turn the page and do the other side. Okay. There's one more problem on this side. It's going to be, you're going to have to write small because it's a long one. This one says 7 squared y to the third z to the fourth all to the second power. So we're going to write it 7 squared y cubed z to the fourth times 7 squared y cubed z to the fourth. Okay, so how many 7's do we have? Well, we have 7 squared and 7 squared, so we have 1, 2, 3, 4. Y cubed and y cubed, so we have 6 y's. Y, 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 y. Then we have z to the fourth times z to the fourth, so we're going to have 8 z's. Z, 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 z. Told you it'd be a long one. So now we get to count total how many of each term we have, or each number and variable do we have. So we have 1, 2, 3, 4, 7, so that's 7 to the fourth. Okay. How many y's do we have? 1, 2, 3, 4, 5, 6 y's. And 1, 2, 3, 4, 5, 6, 7, 8 z's. So let's see if we can't notice a pattern here. We had 7 squared y cubed z to the fourth to the second power. We ended with z to the fourth y to the sixth z to the eighth. So what we did was we did 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8. So here's the rule that we just discovered. When you raise a product to a power, multiply the power, which is the one on the outside, by the exponent, the ones on the inside, of every term, and leave the bases the same. Which means I started with 7y and z and I ended with 7y and z. Okay. So when you raise a product to a power, multiply the power by the exponent of every term and leave the bases the same. So use your observations from the last question to fill in the boxes and complete the math sentence below. So if I have a product of x times y and I raise the whole thing to the b power, what I'm really doing is I'm raising x to the b power and I'm raising y to the b power. So it's sort of like a distributive property for exponents. You can think of it that way since that's really what you're doing. You're distributing the exponent to every single term in that product. Okay. So the law you discovered in the question above is called the power of a product. Use it to simplify the questions below. So if I have a product of 3 times 5 and I raise it to the 7th power, really I'm doing 3 to the 7th times 5 to the 7th. Okay, that's it. You're just distributing the power. So like this one in letter B, 17w squared. This is really 17 times w squared. So I have 17 squared and then w squared. Okay, so this is the power of a product rule. Okay, so this one I have 2 times a cubed times b to the 10th, all raised to the 9th power, which means I'm going to have 2 to the 9th. A to the 3 times 9 is 27. B to the 10 times 9 is 90. So I multiply all the exponents by the one on the outside. Okay, so that's the power of a product.